Solving linear systems using elimination, day 2. We use the elimination method when both equations are in form. Hopefully you answered correctly. We did this same question yesterday. It is standard form. Okay, standard form is which one? Hopefully you choose ax plus by equals c. Remember, standard form is when the x's and the y's are on the same side as the equal sign, and in this case, they are. Yesterday we went through these steps for elimination. Today the steps are exactly the same thing. You have 1, 2, 3, 4, 5, and 6. And we're just going to go over them as we do a problem, but they will be here if you need to come back and look at them in detail. Altering equations using multiplication. Yesterday we started talking about how you want to get a zero pair, and so you can multiply the equation by a number in order to get the x's to eliminate or the y's to eliminate. One of the common issues that I noticed people were having is they were forgetting to multiply the whole entire equation. So for example, if I decide that I need to alter this equation and multiply it by a 2, let's do a negative 2. I would have to do multiplication for every single term. This one, and this one. Another issue I noticed people were having is they were forgetting to put the 1 in front of the variables that didn't have a number. So this one, if I multiplied, would end up being negative 2 times 2 is negative 4x, negative 2 times 1 is negative 2y, and then equals negative 2 times 7, which is negative 14. For the second example, let's say that we were trying to eliminate, and to create a zero pair, we needed to multiply by negative 3. Again, if you don't have a number in front of your variable, put a 1 in front. It'll help you. So this would turn into negative 3 times negative 1, which is positive 3x. Negative 3 multiplied by positive 5y is negative 15y. And negative 3 by positive 10 is negative 30. Now, if you multiply the whole equation by a number, it doesn't change it. If you were to graph the original equation and the new altered equation, they would land right on top of each other. They're still the exact same line as long as you multiply everything by that number. So our first example, 3x plus 6y equals negative 9 and 2x plus 9y equals negative 26. Step number 1 says that equations are in standard form. Yes, so we are done with number 1. The x's and the y's are on the same side of the equals. Now, here's what's different about today. We need to create a zero pair. As I'm looking at the x's, I notice that there's nothing I can multiply one of the equations by in order to create a zero pair. Same thing with the y's. There's nothing I could multiply one of them by in order to create a zero pair. So today we're going to have to alter both equations. And a trick is to use the opposite. So for example, if I want to eliminate these x's, think about what the two numbers would be multiplied together. So example, 3 times 2 is 6. So I'm going to try and turn this into a 6x and this into a 6x. But if they're both positive, they're not going to eliminate. In order to be eliminate, one needs to be positive and one needs to be negative. So let's talk about this. Let's say my top equation I'm going to multiply by 2, and my bottom equation I'm going to multiply by 3. All I really did was the opposite. So like this was a 2, so I multiplied the top equation by 2. This was a 3, so I multiplied the bottom equation by a 3. Now this will end up turning into 6x when I multiply. This will be 6x when I multiply. But one of them needs to be a negative 6x. So what if I went like this? Instead of doing a positive 2, I changed it to a negative 2. So let's see what happens. Negative 2 times 3x is going to give me a negative 6x. Negative 2 times positive 6y is going to give me a negative 12y. Negative 2 times by negative 9 is going to give me negative times a negative is a positive, so 18. And on the bottom, if I multiply everything by 3, 3 times 2x is 6x. 3 times 9y is positive 27y. 3 times negative 26. I'm going to plug that in my calculator. 3 times 26 is 78. And it's actually going to be negative 78. Positive times negative. So now we have our two equations. And we're going to start doing step 3. Step number 2 was to create a zero pair. And we just did create a zero pair with the x values. The negative 6x and the positive 6x are going to eliminate. That's our zero pair. Number 3 says combine equations. So if I combine these, I get 0. Now if I combine negative 12 and positive 27, I'm going to draw you a quick visual on a number line. Here's 0. We're starting over here at negative 12. And we want to add 27y to it, plus 27. So if I go from here to here, that's going to be 12. And then I need to go some more to get in the 27 direction. I'm adding 27. So I'm going to be somewhere over here. I'm just plugging it in my calculator to make sure that it's correct. So negative 12 plus 27 gives me 15. So this would be 15y equals, and then for this, again, I'm just going to plug it in my calculator. I have 18 minus 78. So I'm combining 18 and negative 78, and I get negative 60. That was step number 3. Step number 4 says solve for the first variable. So divide by 15, divide by 15, y will equal negative 4. So we're halfway done. Now you can pick any of the original equations, the top one or the bottom one. It doesn't matter. I'm going to pick the top one. The top equation says 3x plus 6y equals negative 9. And we are going to plug in negative 4 for y, which is right there. So we have 3x plus 6, plug in negative 4, equals negative 9. That leaves us with 3x. Now 6 times negative 4 is negative 24, equals negative 9. Add 24 on both sides. So now we have 3x's equals negative 9 plus 24 is 15. Divide by 3 on both sides, and x equals 5. So our solution is x comma y, so 5 comma negative 4. And I actually had already put it on here in the bottom corner so that we knew if we got it right. I'll do that on your assignment as well. I'll put the answers so you can check to make sure you're doing it right. Example number 2. Both equations are in standard form, and we are trying to figure out a way to get something to eliminate. So I'm looking at the x's first of all, and I'm noticing that if these were both 6x, one of them was positive and one was negative, they would eliminate. So I'm going to take the top equation, and I'm going to multiply by positive 3. The reason why I'm doing positive 3 is because these multiplied together will make 6x, and 6x will eliminate with negative 6x. So 3 times 2x is 6x. 3 times negative 5y is negative 15y, equals 3 times 3, 9. The bottom equation is negative 6x plus 15y equals negative 9. And now we're ready to combine the two equations. So if I combine 6x and negative 6x, they create a zero pair. They are gone. Oh, look what happens. If I combine negative 15 and positive 15, zero pair. If I combine 9 and negative 9, whoa, zero pair. So you'll notice that the x's, the y's, and the answers, they all eliminated. All eliminated. What that would look like is on the left side we got 0 equals, and on the right side we got 0. Whenever you end up with 0 equals 0, that means they all eliminated. Your answer is infinitely many solutions. And what that means is if you were to graph both of these equations, these original ones, your first line would look something like this, and your second line would look something like this. It's literally landing right on top. So those two equations have the exact same slope and y-intercept. So just remember, 0 equals 0 is when they all eliminated, and the answer is, or the solution is, infinitely many. Example 3. Both equations are in standard form. We're trying to figure out a way to eliminate the x's or the y's. I'm looking at the x's right now, and I'm trying to figure out what would I have to multiply by to get one of them to eliminate. Same thing, I'm looking at the y's. I'm noticing that there's not an easy number to multiply one of the equations by to get something to eliminate. If that happens, the easiest way is to use the opposites. I'm going to look at the y's this time just because they have a smaller product. What I mean by product is 6 times 8 is 48. 3 times 7 is 21, which is smaller. You don't have to use that one, but I like to use smaller numbers. So what I'm going to do is I picked that I'm going to eliminate y. And so I'm going to multiply this top equation by 3. And I'm going to multiply this bottom equation by 7. And the reason why I'm doing that is because the 3 times the 7 will give me 21y. And the 7 times the 3 will give me 21y. You're probably noticing we have an issue. In order to get a zero pair or elimination, one of the values needs to be positive and the other value needs to be negative. So I'm going to have to make one of these a negative. So let's say, boom, negative 3. Now let's try. So my top equation, negative 3 times 8x, gives us negative 24x. Negative 3 times positive 7y is positive 21y. And I just lied. It's not positive 21y. It is negative 21y. One of the biggest mistakes you'll make in this category is messing up positives and negatives. Even I do it. And the last part, 3 times 24 is 72. And now on bottom we're doing multiply by 7. So 7 times 6 is 42x. 7 times 3 is positive 21y. And 7 times negative 18 is negative 126. I am using a calculator. I don't have all of these multiplication facts memorized. So our next step is to create a zero pair, which we did. Our y's created a zero pair. Number 3, combine the equations. If I combine negative 24 and positive 42, so we're right here, negative 24 and positive 42, I'm just going to type it in my calculator. Negative 24 plus 42 gives me 18. So we have 18x. Our y is eliminated. And then over here I have a 72 and a negative 126. That means 72 minus 126 gives me negative 54. Finish solving for the variable. Divide by 18. Divide by 18. And x equals negative 3. And I'm just looking over here in the corner at the solution. I got that x equals -3, and it is x equals -3. Woohoo! But I still got to prove the y value. You can pick the top equation or the bottom. It does not matter. Either of these will give you the same. I'm going to pick, let's say, the bottom. I have 6x plus 3y equals -18. And I'm going to plug in for x, and x is right here, and we're putting in a -3. So 6, plug in -3, plus 3y equals -18. Okay, 6 times -3 is -18, plus 3y equals -18. Now I need to add 18 on both sides, get a zero pair. Add 18, whoa, zero pair again. So now on the left side we have 3y equals. On the right side we had a zero pair, so it's a 0. And then divide both sides by 3. And y equals 0. And that is what the solution was supposed to be, -3, 0. Last one. Both of them are in standard form, and we need to create a zero pair. So again, I'm looking at my x's right now, looking at my y's. I'm trying to brainstorm what would be a good number to multiply by to get things to eliminate. I'm struggling to think of one. So when I struggle to think of one, I always just use the opposites. So I make a decision and I say, I'm going to eliminate x. Well, my two x numbers are 4 and 6. So I would do the opposite. So I'm going to multiply the top by 6 and the bottom by 4. And let's see what happens. 6 times 4 is 24. 4 times 6 is 24. So they both give me 24, but in order to eliminate, one of them needs to be a negative. So you pick one and you go with it. I'm going to pick the top. Boom. So now, as I multiply through, -6 times 4x gives me -24x. -6 times -6 gives me a positive 36y. And then -6 times 8 equals -48. On the bottom, 4 times 6 is 24x. 4 times -9 is -36x. Or sorry, y, -36y. And 4 times 15 equals 60. So we just created a zero pair. Our x's are eliminating. Oh dang, look at our y's. They are eliminating. So everything on the left side of the equal sign zeroed out, zero pairs. But on the right side, -48 and positive 60 make 12. So we had an answer like this before. Last time it said 0 equals 0, and that was true. And it was infinitely many solutions. But this time we have 0 equals 12. 0 does not equal 12. If we were talking money and I said, okay, $0 is the same as $12, that wouldn't work. It'd be nice if it did, but it doesn't. If you end up with something like this, where x's and y's eliminate, but the answers do not, and you get a false statement, that means you have no solutions. What that means is your lines will never cross when you graph them. So here would be my top line, here would be my bottom line. They are parallel. They're never going to cross, and that's why you have no solutions. Okay, good luck on your assignment today. Make sure you email me with any questions. I promise I'm here to help. I can do a video call if you need me, and just don't be afraid to ask for help. See you later.